Hi class, this is number 3 on 10.3. A concerned group of citizens wanted to determine whether the proportion of armed robberies in the state of Texas was different in 2011 than in 2010. Research shows that the 113,231 violent crimes in Texas in 2010, of those, 7,622 of them were armed robberies. In 2011, 7,439 of the 104,873 violent crimes were in the armed robbery category. Test at this 0.5 level of significance. So first they say test, do the preliminary work. That is the number sampled. Oh, and we can actually check this now, actually. The number sampled in 2010, is that less than 5% of all violent crimes in 2010? So we can actually find all of the violent crimes in 2010 because they do provide that number. So it sounds to me like they actually want us to do the number sampled I think for this first part, we normally just say yes, yes, and we just kind of wave our hand. They're just putting it here and say, yeah, the answer is yes to these. They're just putting it here to remind you in real life you would have to do this calculation. In this problem, I don't think that they actually want us to do this calculation. I think when they give us research shows that this amount of violent crimes in Texas, I think that's sample data. And of all violent crimes in 2010, I think they don't want sample data there. They want all of the crimes in 2010, not all of the crimes from their little sampled area or whatever. So this needs to be a big N. What they're talking about here is a big N. It's the total number in the population and not the total number from a sample or anything like that. So I think that big N, doesn't sound to me, because they're saying research shows. So to me, I feel like that is a sample. This is all sample data. So it's not information about the entire population of interest. And it's really hard for us to actually, even if we have like all the number of crimes in a certain area, like there's a lot of crimes that probably nobody got caught, right? So we don't even know the real number of crimes. That's a hard number to really come by. And sometimes you can even get robbed and you don't even know that you got robbed, like I don't know, like maybe you just thought, oh, I just thought I lost this money or something, or maybe I thought the person was really my friend and they needed help and actually the person robbed you. But so there's that's another issue too. So and then they say verify the N times P hat times 1 minus B hat is greater than or equal to 10. Now normally when they do this, they use the pooled P, because how do we kind of, oh wait a second, no, they're doing it for the 2010 and they're doing it for the 2011. Okay, so this totally makes sense. So let's do this one here. The numbers sampled in 2010 is this 1,113 to 31. So that's what I'm going to plug in for the small n 2010. in for the p hat, I'm gonna do the 7622 divided by 1311321, because that's the proportion of armed robberies that they had. Okay. Let's see. And let me go to class calc. I'm going to do I'm going to write this out so that I think I'm going to be fine. I think okay. Sorry. Oh, I do need to write those numbers out. Yeah, let's write them out so that I can easily put them in the calculator. So I already have one written out, and the other one is 7622. Okay, so now I have that information in there easily in the calculator here. So 7622 divided by 113231, and that's the p hat that we want right here. It's 0.067. So normally we wouldn't want to truncate that at all. We would try to keep that as accurate as we can. So we're going to do this formula, the p hat, I just calculated it, and then I'll do 1 minus that number, and then I'll do times by the 111 all at once. So if I do times by, let's just do this again. So then I'll do the 113231 times by actually, those are going to cancel each other out, so it's kind of ridiculous. So I'm just going to have, look what's going to happen here. 113231 times by 7622 divided by 113231. But don't you see that they were, when you multiply a whole number of like this whole number or fraction times this fraction, these are going to end up canceling out. So this calculation is going to be like this times 1 minus that. So we can really just cancel out those. But anyways, I'll just enter in the calculation. Times 1 minus, and it's in parentheses 7622 divided by 113231 in parentheses. Okay, there we go. So I put parentheses around the 7622 over 113231 so that it knows that's a fraction, and I'm subtracting that whole fraction from 1. So it doesn't think 1 minus 7622 and then take that whole answer and divide by 113. So I don't want it to think, right, that I'm doing 1 minus 7622 and take all that and divide by 113231. So it's important that I put these parentheses here. I'm not sure the calculator would have understood that I'm doing 1 minus the p hat, right? And this is the p hat, and this is the n, right? So n times p hat times 1 minus p hat, right? And doing that formula. And it's definitely larger than 10. And notice I did not like truncate. It's best not to truncate any fraction, so any decimal. So as soon as I turned this, we saw this above, that when I turn that into a decimal, it's a long decimal, I have to truncate it. So that's why I left it as a fraction in my calculations here to make it as accurate as possible. But let's clear all the drawings, and you should probably do that when you're doing this calculation, because you could get this one wrong just by truncating. If I just use 0.06 in this problem and did, if I did the calculation 113231 times by, if I truncated this fraction as 0.06 times by 0.06, times by 1 minus 0.06, I would have probably got this calculation wrong, right? So it's more accurate to either use all of those decimals and plug them in for right here for the p hat, or to plug in the actual fraction, because that would be more accurate than even writing out decimals out, because they probably truncated this fraction possibly. Some fractions can be infinitely long decimals if you write them as a decimal, right? So that is my answer, 7108.9. So let's see how they like that answer. And that's exactly what they wanted. And then we do the same calculation, but for the 2001. So that's just further, it's further just proving my point here that this p hat, this is my x1, or I say, oh, this is my x1, you can call it, and this is my n1, this is my x2 right here, and that's my n2. So that's just further proving that. When I first read this problem, I thought maybe that this number was the large n, but no, that's not the case. Okay, so the second part here is really similar. We're going to do for the n of 2011, we're going to do 104,873, and then times by p hat, which is a 7439. That's the x value over the n value. And then times by 1 minus 7439 over 104,873. And so you know that this is my p hat. That's my 1 minus p hat. And that's my n, 2011. Right, and I plug everything in, and I just put that all into my class calculator. So let's go back here. And over the 104,873 times by 7439 divided by 104,873, times by 1 minus 7439. Let's see if it does it. Okay, it does seem to be interpreting it correctly. 873. So maybe we don't have to put an extra parenthesis in there, because I do see that it's not putting the 1 minus 7439 in the numerator all over 103. No, it's just putting the 104,873 in the bottom of the 7,000 only. So I believe it is calculating correctly. So 6911.3 is the answer we want here. So that's 69113. So yes. Okay, then we can move on with this problem. Determine the null alternative hypothesis. So we have to really look for the words, and we're listening for the words, and you test the claim, or we're interested is less than, more than, changed, different, right? We're looking for those words in this problem when we look for the alternative hypothesis. And we know that the information, the numbers that are going to be, actually there's no numbers in the null alternative hypothesis. We're only looking for a symbol here. So I'm literally only looking for less than, greater than, or change. So a concerned group of citizens want to determine whether the proportion of armed robberies in this state was different in 2011 than in 2010. So different automatically means not equal, right? Because it could be less than or equal to, that either way. So it's just not equal to. The same thing that we has said has changed. We want to know, has it changed? It means not equal. So our alternative hypothesis is not equal, and then the null hypothesis is always the opposite, or sometimes it's just solely the equal sign, which here the opposite of not equal would be equal. So now I just put all my information into my calculator and get my p-value. So this is a proposition test. It's a 2-sample proposition test. So I go to stat, tests. And then I go to two sample prop Z test. Oh, and I'm going to delete all this other information that I got in here before that test. Should just X out of that. It tells me it wants the X1, N1. Now, with a left tail test or a right tail test, it's very important. What is your pop X1? One is what population? Is that 2010 or 2011? In this problem, because it's a just different than, it doesn't really matter whether we make which population. However, normally this is how I do it. Whatever population they mention first when they're like listing all their data out and stuff like that, that is the one I usually go with population 1. So they said research shows that 111 violent crimes in Texas in 2010. So they give me the information for 2010 first. So I'm going to go ahead and let that be my population 1, and then this would be my N1. Then that value would be my X1. And I erased it, but this is of all of these. So that's the total number of people sampled, N1. So many of them had a certain characteristic. So that's my X1, that's the desired characteristic, number of those that have the exact desired characteristic, right? And then, so this is my N2 population. 2011 is my second population, so N2, and that's my X2, okay? And like I said here, if you mix this up, I mean, there's no really mixing it up because they don't tell you any particular way to really do it. I'm just like going with which first population they listed for me first. But well, actually there is kind of a wrong way to do it. If you're doing a left tail test or right tail test, there's only really one. You kind of have to have picked the right population. But this test doesn't matter. So with a two tail test here, with that, when you have a not equal test, that's a two tail test. Okay. So I'm going to do cast calc, and I'm going to enter in the X1. Oh dear, and now I have them. Now I didn't write them. Let's go back. The X1 was equal to 7622, and the N1 was equal to 113231. 231. Oops. We're going to slight little different there. Probably would have thrown our answers off. And the X2 is 7439, and N2 104873. So now I can do two prop Z test. My X1 is the 7622. The N1 being the, where did I write that? Oh, there it is. It's just behind everything. It's the 113231. Then the X2, the 7439. N2 104873. Okay, and then it's not equal, so the p-value that we want is this value right here. And here's the Z statistic. So it's 0.0008, 3 zeros and an 8, which actually would round to a 9 if they wanted to round to 4 decimal places. They may round to 2 decimal places, which would say 0, and then it's negative 33.3. Okay, so double check our answers here. So that is the negative 3.3, and it is round to 4 decimal places, 0.004849. And then you have to ask yourself, do we make a decision? Do we reject the null hypothesis or fail to reject the null hypothesis? And we have to look at our level of significance, and we have to compare p-value to alpha. The level of significance is 0.005. alpha is 0.0005. Did I just say 0.005? No, just 0.05. Okay. The p-value is 0.0000930. You can be real careful there. Okay. So this, you can kind of think about this. These two decimals, you have to compare them and tell me which one is larger. And you could think about this as zero. This is, in money terms, this is 0 dimes, 0 pennies, 0.1 of a penny, and 0 or 9/100ths of a penny, which is really, really small, right? Over here, we have 0 dimes and 5 pennies. Which one is larger? 5 full pennies or 9/100ths of a penny? So yeah, that alpha is going to be larger. So the p-value is less than alpha. So we reject the null hypothesis. Another way of comparing decimals, if you're having trouble with comparing decimals, is what you can do is you you take I have 4 decimal places, 1, 2, 3, 4, because there's 4 numbers to the right of the decimal. I add zeros after the shorter decimal, the one that has less decimal places. I add zeros until they both have 4 decimal places, 4 numbers to the right of the decimal. Now I can completely erase the decimal and any preceding zeros, zeros to the left. Same thing here. And now I just compare 9 to the number 500. So 9 is a lot smaller than 500. So that's why 0.0009 was smaller than 0.05. That's comparable comparison. So comparing 0.0009 to 0.05 was a lot like comparing 9 to 500. So you notice that 500 was the larger number. And so sometimes that kind of clears it up and you can kind of say, oh, yep, 0.05 is bigger, okay? So the next one here says, so we reject the null hypothesis. So this is a major thing that we did something here. We reject the null hypothesis. So we say there is sufficient evidence. And what they should have said here is there is sufficient evidence to support whatever we said in the alternative hypothesis. And if you look up here, we said that the proportion in 2010 was not equal to the proportion in 2011, which means there's probably either more violent crimes in 2011 or less violent crimes in 2011. We don't know, but there was something like that going on. Most likely because we called this population 1 and that population 2. So they subtracted 1, they took 1 and they subtracted 2 and they got a larger number here. So that it looks like to me that probably the one in 2011 was a larger proportion, and we can kind of even just calculate the proportion up there. So, well, anyways, for our sake for this problem, if we say reject the null hypothesis, we always say there is sufficient evidence to support the claim that the armed robberies is different than in 2011, 2010. It's exactly the claim that we were saying that we wanted to prove. So there is sufficient evidence to prove the claim that we wanted to prove. That's what we want to say in this final conclusion. And if I did say, which I'm not saying this one, but I'm just saying, if we fail to reject the null hypothesis, we fail to have sufficient evidence. We do not have sufficient evidence. So if you reject the null hypothesis, there is sufficient evidence, and those always go together, okay? And if I fail to reject or I do not reject, then I do not have sufficient evidence. Those two always go together as well, okay? Alrighty. I hope you found this really valuable, and I hope that it's gave you information. But help Please email me if you have any questions. Bye.